Hey guys, it's Chili here. Welcome to part 2 of tutorial 17, where we are going to solidify what we learned in part 1 about inheritance, and we're going to use it to implement a different type of class inheritance. Along the way, we're also going to learn a different use for the mutable keyword. It's not just for lambdas, but most importantly, the code that we establish here is going to set the stage for the next couple of videos where I teach you the powerful concepts of virtual functions and polymorphism. You know, in the last video when I introduced inheritance, we did it by, well, we had a concrete class smasher and we wanted to extend its functionality without changing the smasher itself. So we created a new class, elite smasher, that inherits from concrete smasher, and we use that to extend the functionality. So that's one example of inheritance, extending an existing class without modifying it in any way. Now another place where you often use inheritance. Let me give you a little setup here. So let's say you're making a program and it is going to be modeling a company, all right? So company has personnel, different kinds of personnel. It might have factory workers, researchers, engineers, janitors, office workers, etc. Okay? So let's say you start off, you're going to make classes for each of these types of personnel. So you create the factory worker class. It's got age, name, address. It's got some member functions, maybe like assemble, because he's doing assembly on an assembly line. I don't know. Now you're going to create your second class, your researcher class, and the researcher is also going to have age, name, address, and you think to yourself, well, you know, maybe I shouldn't be, you know, repeating myself here. Maybe I should use inheritance. So I don't know what I'm going to do. I'll make the researcher inherit from the factory worker, and then he'll get all of these members. But that's not good for two reasons. One reason is the researcher should not have access to the assemble member function. That's only an operation that a factory worker is going to be using. So you don't want to inherit all the things of factory worker. And the second reason and the main reason is, remember I told you inheritance, that's an is a relationship. Is a researcher a kind of factory worker? No, they're completely different workers. So this kind of inheritance is not applicable. It's not valid. Don't do that shit. So what is the answer? Well, the answer is you look at the things that all of these positions have in common. Well, they're all going to have an age, they're all going to have a name, they're all going to have an address, etc. They're going to have a bunch of member functions that are in common, and you factor that out into some base class, some generalization. So you create a new class called employee, and it has all of the things that are common to all of your employee types, and then every employee type inherits from this general base class and gets those things. And then each of these specific employee type classes will implement the stuff that is specific to their employee type. And now we see that this does not violate the is a rule, because a factory worker is a type of employee and an engineer is a type of employee. So it's all good. And this is different than the previous example, because we're not extending an existing type. We're creating a new general type in order to factor out all of this common functionality, and to bring all these related types into a single organized hierarchy. In fact, you're never going to instantiate just an employee. You're always going to instantiate an engineer or a janitor or an office worker. So what you could do is you could make the constructor for employee, you can make that protected so that only these guys can access the constructor. You can't create just an employee. It doesn't make any sense. It has to be a specific type of employee. And we call this kind of class, a class that isn't actually supposed to be instantiated, we call that an abstract class. And the classes that are supposed to be instantiated, we call them concrete. And we'll talk a little bit more about abstract classes when we get into virtual functions, because they're related. Another thing you can do is you can make this work on multiple levels. So, for example, office worker, you might make some more specific types of office worker, human resources versus, you know, an accountant. And you could make office worker also abstract now, and then these guys would inherit from office worker. And again, this does not violate the is a human resources worker and accountant are both types of office workers, and office worker is a type of employee. It all fits logically into this hierarchy. Now, one thing that doesn't fit is, well, for example, let's say we're going to make a class for a building. And, well, building has an age and a name and an address. So let's inherit building from employee. That would be great. We can reuse a whole bunch of code. No, never fucking do this. This is retarded. A building is not a type of employee. They're completely different. Doesn't fit into this hierarchy. So even though you might look at it, a situation, and say, I can get some code reuse here, I can make it cool, I can inherit from this thing and get a whole bunch of functions and I don't have to repeat myself. But no, first rule is it an employee? If it is not an employee, don't inherit from employee. That's dumb. Inheritance is a relationship. Okay? Cannot make this any clearer. All right, now what I'm going to do is I'm going to implement a system that has an inheritance hierarchy, just like I described. Now, you can't just kick back and watch me work here, but if you're strong enough, I recommend that you attempt this on your own before watching me. So you go to the inheritance repo on my GitHub. This is the same one that we used for part 1. And you can branch off at this commit here, meme fighter start point, and you'll have this code here. This is a starting point. It has the main function, and this you have to implement the classes for this code. Now on the wiki, there's a section, part 2, class specification, and this tells you the things that the classes have to implement. So I mean, obviously we've got 2 concrete classes here, meme frog and meme stoner. We can see them being instantiated here in main. So we're going to need those classes, and we're also going to need the base class that they both inherit from, for 2 reasons. First of all, because we don't want to be copying or duplicating this code and this data in 2 separate classes. And the other reason is because, well, we need to. Here we have a function engage, which basically pits 2 fighters against each other, and it takes a reference to meme fighter, so that it's going to have to take a reference to a base class that all of the fighters inherit from. So our base class is going to be named meme fighter, and then meme frog and meme stoner are going to inherit from that. Now meme fighter, it's going to have name, HP, speed, and power. So let's do that right now. So we go meme fighter. It's got HP, speed, and power. They're ints, and then it's got a std string for the name. Now I've made these protected because if you look at the specification for some of these guys here, the meme stoner has a special move function that takes no parameters, has a half chance of adding 3 speed, increasing power, and adding HP. So obviously these inherited classes, these child classes, they're going to need access to this stuff, and the easiest way to do that for us is to make them protected. Now the meme fighter requires a few getters. First of all, we're going to need a getter for the name. That's pretty standard, no explanation really required. Now we're also going to need a getter that lets us get the alive state of the fighter, whether it is alive or not. So it's going to return a bool. So we create a function is alive, and we're just going to return HP greater than 0, because if HP is 0 or less than 0, that means that that motherfucker is dead. Now the last getter is for initiative, for the character initiative, and this is, you know, when they attack each other to determine which one attacks first. You roll initiative, right? And initiative is just speed plus 2d6. So you've got to roll 2 dice, add your speed, and that is your initiative value. Now, we don't have dice. We could handle this a couple of ways. We could make any function that requires rolling. You'd have to pass in a dice, a reference to a dice object. But what I prefer to do is just embed a dice object into our class here. And we can make this one private. The outside world doesn't need to know about the dice. And what we're going to do, well, I mean, I've got a dice class right here. All I've got to do is make myself some dice, call that D, and there you go. I've got some private dice. Now I'm going to give myself a protected function because I still want my children to be able to roll my dice. So I'm going to make a protected function. I'm going to call it int roll, int n dice equal to 1, so default to 1 die. And rolling, I want that to be const, because, for example, my getter for getting initiative, I want that to be a const function. That's just a getter. Now the problem with this is when I do this, when I do return d.roll in dice, we're going to have a problem. And the problem is that the roll function isn't constant, because it's going to change the state of the RNG. It's going to change the state of the distribution whenever you call roll. So I can't roll inside of a const function, but there are const functions in which I want to roll. How do I resolve this? Well, there's a specifier here, a modifier called Mutable. You may have remembered it from when I taught you lambdas. And what Mutable does on a member variable is it says that even in the case of a const function, you're allowed to change it. Now, it's easy to abuse Mutable and just make everything mutable, but that kind of defeats the purpose of making constant member functions, right? So you've really got to have a good reason for making something mutable. And my reason for the dice is the dice, they don't represent anything about the state of my entity, right? It's just random shit, right? It's not anything about the definite state of my simulation. So I think it's okay to make random number generators stuff mutable in many cases. So that's what I'm doing here. And now my roll function is const, so I can call it, my children can call it from const functions. So let's make the get initiative function. Yeah, it's just going to look like this, return speed plus roll 2, and there you go. We've got our getters done. Now the next thing we need is we need a function that allows one entity to punch another entity, right? So how do we do that? That's going to look something like this. And the first thing we do in here is we make sure that both entities are alive. Otherwise, it doesn't make much sense for one to be punching the other. And if they are, we announce that entity 1 punches entity 2, and then we call apply damage to. So I'm going to make a function that allows me to apply damage to another entity. Well, I don't want the outside world just to be able to directly apply damage from one entity to another. So I'm going to make the apply damage to function protected. So there's the punch function all worked out. The damage is just power plus 2d6, by the way. Now, the last one is the tick function. Now, what the tick functionality does is it's called every turn. And what it does is it allows the character to recover a random amount of HP. So the amount of recovery is just 1d6. So that's really the entire interface implemented here for the base class, the meme fighter. Now, one more thing we probably want to add here is a constructor. But since no one will be creating a meme fighter, it's an abstract class, no one will be creating a concrete instance of meme fighter, we can make the constructor protected. And here it just takes the name, the HP, speed, the power, all of the parameters, and initializes them. And it also prints out a little message here, whatever's name enters the ring. Just a little optional bit of flair there. And there you go. There's our entire base. All right, now we need to implement the two concrete types, the meme frog and the meme stoner. So we go class, meme frog, and the colon, public, don't forget the public, meme fighter. And now we are inheriting from meme fighter. We have all of its shit, and let's add some of our own shit. So what do we want? Well, we got public here. We're gonna need a constructor for the meme frog. And that's gonna look something like this. The meme frog, it has specified, I've told you what these parameters must be. So the only thing you set for that is the name. So it takes a name, it sets up all of the attributes of the meme frog. Next thing we want is we got the special attack, or really I should call this special move. And the special move function takes an other meme fighter, a target, and again, first you make sure that they're both alive, and this one has only a random chance, has a 1/3 chance of succeeding. So you roll, and if that is greater than 4, then we say that we attack the other one with the rainbow beam, right? Because frogs, you know, they're putting chemicals in the water, making frogs gay. You get the idea. Anyways, so yeah, and then we call apply damage to. Very nice that we had that function there. And we apply damage to the other. And the roll is, it's 3d6 plus 20 damage. So it's a small chance of happening, 1/3, but it does some good damage. Otherwise, it doesn't do nothing. We just, we say, I don't know, the frogman falls off his unicycle, whatever, it doesn't matter. So, that's a special move. Now, the last thing is that meme frog, We see here that meme frog takes 1d6 of damage every turn. You know, the turn the frog's gay, they got AIDS, I don't know, whatever. Doesn't matter. So, it takes 1d6 of damage every turn. Now, we know that tick is called every turn. So, let's override the tick function for meme frog. So the first thing we do is we check to see, you know, if it's alive. Only living things tick, right? And if it is alive, then we say that we are hurt by the bad aids. We apply damage to ourself, 1d6, and then we call the base class tick function to get the recovery, because we still get that effect. I didn't say that you don't that you lose that effect. Now the other concrete class that we're implementing is the meme stoner. So we're gonna have a constructor. We're gonna have a special move. We are not overriding the tick function because the meme stoner doesn't have any special tick functionality. So we can just use the parent as is. The constructor is the same idea. And for the special move, the special move is basically a buff. So it gets +3 speed. It gets a power increase by a certain factor. We multiply by 69 and divide by 42. And it gets a little bit of an HP recovery there. And it also changes the name. So what I did was I just added super before the name. And then you've got this little announcement here. Now, this special move can only happen again if you're alive, and it only has a 50% chance of occurring. So if roll is greater than 3, we do that. Otherwise, we just, print out a dumb message and we don't do diddly squat. And there you go. We have implemented our hierarchy of classes. And now this should enable our code here, the code that was supplied, to work. So let's see if it builds. So that boy and good guy Greg enter the ring. Greg punches that boy for 16. That boy punches for 26. Greg smokes the dank sticky icky, becoming super good guy Greg. I guess I should have put a space in there. That boy falls off his unicycle, so he doesn't do his special attack. He is hurt by the AIDS, takes 6 damage, recovers 3. Greg recovers 5. Again, same idea. That boy does not get his super in. Good guy Greg smokes the sticky icky, becoming super good guy Greg. And stuff happens again. Let's see. That boy just can't get a breaker. He's not getting his super in there. And the super good guy Greg, super good guy Greg is victorious. All right, so for the message here, we are adding the space when we modify the name, but we're not adding the space when we just give the message here, because that happens before we modify the name. So we'll add the space in there. Let's run it again. Let's see if we can get some, we can see if that boy can do some good shit. Here we go. That boy attacks super good guy Greg with a rainbow beam, 34 damage. What do we got? Then that boy punches super good guy Greg for 20 damage, and that boy is victorious. So there you go. So there's a slightly more involved example using an inheritance hierarchy with an abstract base class. And yeah, you could extend this. You could add any different kinds of meme fighters in here just by inheriting from the meme fighter base class and implementing whatever special functionality you want to implement in there. And we are going to be taking this system and expanding on it in the next tutorial about virtual functions. And there you have it. You got your 2 main scenarios for class inheritance. Number 1, you want to extend some existing type without touching that type, without fucking with it. And the second type of class inheritance is where you have a hierarchy of types. So you've got some base class that defines all the common functionalities of the different concrete types in your hierarchy. And then you just inherit from that base and you override and extend to specialize into the concrete type. So generally the base class is often often an abstract class. It's not actually instantiated. It just exists to basically factor out all of the common functionality of your actual types that will be in the system that you'll be creating. By the way, this class diagram here, you can get it by, if you go to class view here, you can see all your classes in your project, and you can expand those, see the derived types, you can click on them, see all the members. But if you right click, you can go view class diagram, you can put class in here, you can drag some other classes, and you'll see the relationships between them. You can expand them, move them around, all sorts of crazy bullshit. I don't really use this that much, but it's something. Now, just 2 points of advice here before I end the video. First off, never ever break the is a rule, okay? That's the one thing I want you to do when you're using inheritance here. Don't try to shoehorn things into an inheritance hierarchy that don't fit. It's bad because it makes your code harder to conceptualize and understand, and it's bad because it usually leads to actually just bad code. The other thing I want to mention that I mentioned in part 1 again is don't go too crazy with this inheritance stuff. It's just one tool among many and it can be abused. In the next 2 videos, I'm going to talk a little bit more about inheritance and its place in the bigger scheme of things and, alternative techniques to inheritance. In fact, what I've been showing you guys up until now, it's been important, it's been necessary for me to show you this, but this isn't the true power of inheritance. Next video, I'm going to teach you about virtual functions, and they are going to unlock the ultimate potential of inheritance in C++. This isn't even my final form Frieza.jpg. That's what I'm trying to say here. But until then, thanks for watching. Hope you enjoyed the video. If you did, please click the like button, it helps a lot. And I will see you soon with some more C++.